Welcome to Mbuya Parent School and Kindergarten, situated in Kampala City with modern, well-equipped facilities plus extensive playing fields and amenities. Mbuya Parent School believes that a better future lies where children know how to find and create balances in themselves and the world around them. This explains our fusion of academic subjects and co-curricular activities. There are many opportunities presented to them to flourish both in and outside the classroom.
I want to become a president when I grow up.
I want to be a pilot.
I will be the best fashion designer.
Mbuya Parent School. The sky is
Good.
our limit.
Our beautiful learners, greetings from Mbuya Parent School. Once again, here comes Teacher Salim with mathematics, lesson 5. I've loved it when you're following us on our different platforms, the Facebook, the WhatsApp, and the YouTube as well. Please keep it up. I'll keep responding to your various inquiries, as I've always been doing. Previously with teacher Isiko Moses, you looked at a kite. You looked at the area of a kite and how to find the unknown. Please, I want to build from there. When we're looking at your responses, we got to realize that number 3 challenged 20% of the class. How I wish, before I look at the next lesson, to help you answer question number 3. Here with me was the activity that teacher Isiko Moses left you with. Basically, number 3. It goes. Number 3, study the kite below and answer the question is attached. In the very first place, before you begin attend to any question class, I beg of you, look at the polygon, interpret it, define it, look at the properties of that polygon, and that will guide you to answer all the questions that are related. So look at this figure here. It is a kite, as it is stated in the question. Then in the very first place, we need to define what a kite is. Class, we defined a kite as one of the quadrilaterals having 4 sides. We also went ahead and looked at the lines of folding symmetry. We actually said a kite has gotten only one line of folding symmetry, and that is passing through at the leading diagonal, the one we can also term as the major diagonal. I don't want to waste much time. Let me go straight forward to the question. This is the kite we've been given, and part A of the question, they actually want us to find the value of n. Here comes our value of n. We have various sides. We have this side here, 17 meters, which is equal to this other slanting side here, 17 meters. You lose nothing if you do write them there. This side here, according to this figure, it is clearly stated that this side here is equal to this side here. This side is equal to this, whereas this n is equal to this. So if this is n, you lose no mark. Class, I beg, you lose no mark if you go ahead and write this n that way. So let's go direct to the value of n. Previously in all lessons been sharing with you, we looked at how to apply Pythagoras theorem, and that does with only right-angled triangles. So please, before you go ahead in finding the value of n, you need to extract one right-angled triangle in this figure and then apply Pythagoras theorem, and then you'll automatically get the value of n. Let's pick out one. We are going to pick out just one. Learners, I like it when you're moving with me. I really enjoy it. And you've been doing that one always. We are extracting a right-angled triangle. Please indicate that symbol there. And the slanting side, which is also known as the hypotenuse, has been given as 17 meters. At the end, which is also our base, it is there. At the height of the right-angle triangle is 15 meters. At that point, we can now apply our Pythagoras and get the value of the unknown, which is n. This one can be baptized as A, this one as B, and that one as C. The theory of Pythagoras theorem is very clear. It says that the square of A plus the square of B is equal to the square of C. As I said, I like it when you're moving with me. Having stated the formula, go ahead and substitute in. What is our A? Class, our A is n. So the index of n, that is n raised to, plus our B, which is 15 meters squared, will give us our C, which is 17 meters, a class squared. Hope you're all moving with me. I really love it. Having substituted in, we now go ahead and expand. Let's expand together. This one remains n raised to class 15 times 15. I know you're moving with me. That will give us 225 meters times meters. That will give us meters raised to, will give us class 17 times 17. I know you're moving with me. That will give us 289. Then meters times meters, it will give us meters raised to. Having expanded that level, we now go ahead and collect like terms, whereby we shall remain with the n squared this side, and then we take the 225 the other side. Hope you're with me, class. Together we do it. N raised to plus 225 meters squared minus 225 meters squared. Class, I will borrow part of the lower part, will equal to 289 meters squared minus our 225 square meters. 225 square meters. Continue. We shall remain with n raised to 225 meters squared class minus 225 meters squared shall give us a 0. So 289 minus 225 class. I like it when you show the working. I really like it when you show the working. You lose no mark. If you come this one, say 289, take away the 225. Class 9, take away 5. I love that. That gives us a 4. Good. 8, take away 2. Perfect. That gives us a 6. 2, take away 2. You are the best. It's giving us a 0. So we shall have 289 take away 225, giving us 64. Please do not forget the units. That is a square and meters. At that point, class, you can now go ahead and introduce the square root symbols as one of getting the square root on each side. Class, we have our n raised to giving us 64 square meters. As I said at that point, let's now get the square root. In the very first place, begin by introducing the square root symbols, square root symbols. When you multiply n 2 times, you get n squared, meaning that the square root of n squared is n. Look out for a value, a digit, a number, that when you multiply it twice, you get 64. Without wasting much time, you must have gotten the answer there. It is 8. 8 times 8, we get 64. Meaning that the square root of 64 class is 8. I wish to use the same color. It is 8. Then the square root of meters squared, it is meters. Class, at that point, I must tell you that we've accurately answered part A of the question, which is telling us to find the value of n. Get a ruler, double underline your answer. I like the neatness. I like the neatness. I like it when you are neat in your presentations. Class, without wasting much time, I wish to go to part B. Calculate its area. Calculate its area. You started this with the teacher Musoko. You shared it with teacher Isiko. Allow me to build on that. We looked at area of a kite. We stated it clearly that area of a kite is given from the formula a half times the product of the two diagonals. That is diagonal 1 and the other diagonal 2. Class, hope you still remember that. However, before you substitute in, it is very important for us to know the major diagonal, that's diagonal 1, and then diagonal 2. So the question to answer in this case is, what is our diagonal 1? Let's get back to our figure. Here comes our figure, class. This is the leading diagonal. Hope you're with me. This is the leading diagonal. So it runs from this vertex to the opposite vertex, from this corner to the other corner. So we have 5 and 15. So the sum of 5 and 15 shall give us the leading diagonal. So for that reason, therefore, our major diagonal is equal to 20 meters. Good. Let's look out for the minor diagonal, which is diagonal 2. I love that. Let's get back here. This is our minor diagonal. It runs from this vertex to the opposite vertex, meaning that if this is n, since these two are equal, if this is n, this will be n. So the sum of the two n shall give us the minor diagonal. So that is n plus n. Back to the value of n. We've gotten the value of n as 80 meters. So our minor diagonal shall be 8 plus 8, plus our minor will automatically be 16 meters. I like it when you show the working. I really love it when you show how you're coming up with the final answer. However, the question is calling us to find the area, to calculate the area. From our formula, we've got to know that area of a kite is given from the formula a half times the product of the two diagonals. Having set the formula, you are allowed to substitute in. Continue. We have a half times our major diagonal, which we've gotten here as 20 meters, times the minor diagonal, which we've gotten as 16 meters. Hope you're with me. I love that. Let's go ahead and reduce. Class, by 2, we shall get a 2, and by 2 here, we shall get a 10. And then we maintain the units. Very, very important. Let's continue. 1 times 10 meters, class, we get 10 meters times the 16 meters. Perfect. Finally, our area shall be 10 times 16, which is 160 meters index 2. And that will be the area of the kite. Here comes again your teacher with lesson 5. And basically on a new polygon, and that is a trapezium. We looked at a rhombus. We've shared about a kite. Today, I want to share with you part of what is involved in this new polygon, which is a trapezium. Basically, in this class, I want to be smart. We're only going to look at finding area. Finding area of this polygon, which is a trapezium. Note, area of a trapezium is obtained from the formula a half times height into the sum of A and B. I wish to share that one with you. A half times a half, a half. It is a half h into the sum of A plus B. Class, that's not enough. And I don't want you beautiful learners to limit your answers, your other alternatives. If this one is a little challenging, you are allowed to say that if I want to get area of this figure, I can also partition it into various figures, get area of each, then add the two. Looking at this, class, look at this is a trapezium. It's actually in line with what I have drawn here. Exactly. In the very first place, I don't want us to take it for granted that it has to be in this. Today it is facing that side. The other day you'll find it here. Class, it remains a trapezium. Another day you'll find it upside down. I must say clearly, it will remain a trapezium. Some other time you'll find it facing the other side. Still, it remains a trapezium. So here comes my trapezium. As I said, we look at this. We can get as many other figures as possible. Because I can partition this. and have a triangle, I have a triangle, I have a triangle. I can partition it as many as I wish, but for purposes of not getting confused, I dislike it. We are only going to have 2 figures out of it. So look at this. When I cut off this triangle here, hope you moving with me. Class, I really like it when you are moving with the teacher. Good. It was a trapezium, but now I have divided this figure into 2 parts. You get it? Now this is a rectangle, and this is a triangle. So when I get area of this rectangle, and I get area of this triangle, I put the 2 together. Automatically, I will be getting the area of the trapezium. I'm going to apply it in this first example. Here comes our first example. I want us to read together. Find the area of the following figures. The figures are basically 2. Let's begin with the first one, which is our part A. I love it when I redraw it. I really love it. Class, hope you are with me. You can as well get a book and start moving with the teacher. I love it when we all move as a team. This is P, Q, R, and S. We have that right angle. S and R is 15 centimeters. Beautiful. Line PS is 6 centimeters. Wow. And then line PQ is 8 centimeters. So at that point, we can now get area. So we are going to use the 2 approaches. At the end of it all, you will say, teacher, I found the first approach. Very comfortable. Good. PQ is 80 centimeters. And at that point, we can now get the area of the figure. Which figure is a trapezium? From the first principle, I want first to use the first formula. We have it clearly here. Area is equal to a half H into the sum of A and B. A is the shorter side, whereas B is our longer or long side. So shall we now go ahead and substitute in, having stated the formula. Let's do it together. A half times the value of our height. Class, our height is standing at perpendicular, and that is 60 centimeters. Hope you're with me. Into our A, which A is 80 centimeters, plus our B, which is 15 centimeters. I know you are moving with the teacher. That is beautiful. It is beautiful. Tell yourself that is beautiful. Go ahead and reduce. Class, by 2 shall get a 1, and by 2, class, we shall get a 3. So we have 1 times 3, that gives us 3. Don't forget the units. Times the sum of 8 centimeters plus 15 centimeters, which gives us, I love the answer, 23 centimeters. Perfect. So we now need the area. Class, you lose no mark. If you come this one, say, I want to do it vertically. I have 23 times 3. Good. Class, 3 times 3? Wow, that's 9. Good. 3 times 2? Perfect. That is 6. So we shall have our area as 69. Don't forget the units. Square centimeters. At that point, get a ruler, and double underline your answer. For purposes of neatness, and whoever will look at your work will say, yes, this candidate must have been taught by teacher Salim. Let's continue. I said we can also use the other approach, because one may find this one very easy. Another one say, no, teacher, at least the second approach was very okay. Approach 2. The second approach. I said we can get area of the various figures and then sum them together. This was my figure. I want once again to share it with you. This was my figure before cutting it. I want to be a little smarter. The figure was a trapezium. When I cut it, I got two polygons. One is a triangle, another one is a rectangle. So when I get area of this triangle and I get area of the rectangle, I add the two, trust me, I'll get the area of this figure, which is a trapezium. And it must be exactly to this, because the same figure I've cut into two parts. Class, let's do it together. I like it when you are moving with the teacher. So we've separated it into two. I'm going to do it here at the board. I'm separating it. I have that right angle for the other triangle. Together we are going to move together, class. I have P, Q, R, S. Please, could we present our P, Q, R, S, T? I can make that one. T, let me use a different color. Let me use a different color. T. So what is remaining? For this rectangle, we have everything. We have the length, 8 centimeters. We have the width, 6 centimeters. Trust me, with the triangle, we have the height, 6 centimeters. But we do not have the base. Trust me, we can get this base with a lot of ease. We know that from this point P2, it is 8. This is also 8. But from this point to this point here, the whole line is measuring 15 centimeters. What does it mean? To get TR, we shall say the whole of it, which is SR, which is measuring 15 centimeters. Hope you're with me. SR measuring 15 centimeters, 15 centimeters minus ST, OP2, ST, which is measuring 80 centimeters. 80 centimeters. It is measuring 8 centimeters. Hope you are moving with me, class. What remains after we've subtracted will be for TR. So our TR, length TR, will equal to, class, what's the answer? Good, you're the best. 7 centimeters. So having gotten the base of the triangle, trust me, we can now get the area of the figure. Let's do it together. You can say, please, teacher, let me have this one as my first figure A. This is my second figure B. Get area of A. Get area of B. Add the two. Trust me, you'll have gotten the area of the trapezium. Let's do it together. The first one, it is area of A. If you look at it, it is a rectangle. How do we get area of a rectangle, class? Good. That is length times width. I love it. What's our length? Good. Our length is 8 centimeters. What is our width? Perfect. 6 centimeters. Continue. Class 8 times 6. You are the best. That is 48. Do not forget the units. Square centimeters. Good. So that's for only A. We also need to get B and then get the sum. So area of now B, this one here. Now look at figure B is a triangle. We know area of a triangle is a half times base times height. Hope you're with me. A half times the base, which we've gotten, which is our TR, 7 centimeters, class times the height, which is 6 centimeters. We can now go ahead and reduce. However, 7 is not a multiple of 2. However, 6 is. So we can reduce by 2, it is a 1, and by 2, class, it is a 3. So we shall have our area giving us 1 times 7 centimeters, which is 7 centimeters, times the 3 centimeters. Hope you are with me? Good. So we have 7 times 3. Class 7 times 3, it gives us 21 centimeter times centimeter. It will get a square centimeter. So that is now area of B. So we have our A. As I said from the beginning, I like it when you are smart. I like it when you are smart. And keep the smartness. So we have our area of A. We have our area of B. Let me get back here. We have our area of A. We have our area of B. Put the two together, get the area of the figure. So area of the trapezium in this case, area of the trapezium, which is our figure, will equal to A, area of A plus area of B. Our area of A, class we have it as 80 square meters, plus area of B, which we have it as 21 square centimeters. Hope you with me? Get the sum. As I said, you lose no mark. If you come this side and say, teacher, I have 48 plus 21. 8 plus 1, good. Giving us a 9. 4 plus 2, wow, that is a 6. So our area in this case will be 69. Do not forget the units. As I said, I want to emphasize, underlining makes your work look neat. Do it just as your teacher has done it. When you can compare these two, the first approach, we use this method here, we got our 69. That was the first approach, square centimeters. Go to approach 2. We've got the area of the first figure, area of the second figure. We added the 2. Trust me, we have gotten the same answer. Hope you are moving with me. Good. Allow me wind up with example number 2. Example number 2. Beautiful learners, I want to summarize with example number 2. And in this example number 2, I'm only going to use one approach. It will now be upon you to choose which approach have you found very convenient to use. So I've chosen to use the very first approach. Remember, we are finding its area. Which figure? A trapezium. It's very important before you start. Identify the figure that you're dealing with. It is given from the formula, a half times height times the sum of A and B. Hope you are with me. Let's continue together. Having stated the formula, class, the second step is now substituting in what you have. We have the constant a half times our height, which has been given as 70 centimeters, times, open the brackets. What is our shorter side? Plus, good, 4 centimeters, plus. What is our longer side? Wow, that is 8 centimeters. Good. You can now go ahead and now simplify. Step number 1, state the formula. Step number 2, substitute in. The second step now will be simplifying. We look at 7 and 2. 7 is not a multiple of 2. Leave it at that point. Try to see if there are some other multiples before you begin dividing. We have our a half times the 7 centimeters times class 4 centimeters plus 8 centimeters. Wow, good. That is 12 centimeters. At that point, we look at the 12 and 2, you'll see something in common. So 12 is a multiple of 2. At that point, you can now reduce. Class by 2 shall get a 1, and by 2 here, class shall get a 6. So we are now having area is equal to 1 times 7 centimeters. It gives us, good, 7 centimeters, times the 60 centimeters, times the 60 centimeters. Class 7 times 6. You are the best. 42. I like it. Centimeter times centimeter. Good. Centimeter squared. So our final answer will be 42 square centimeters. I like it when you don't forget to underline your answer. I love it. Now, class, as I said from the beginning, I'm not going to use the second approach. The first approach is enough. However, you can also use, actually I'm giving it to you as the very first trial before you attend to my activity. Get out this figure. Divide it into 3 parts, as you can see your teacher. I'm trying to divide it into those parts. Are you with me? Good. I have that figure. I will show you that figure that I've cut out. I also have this one here. Hope, beautiful learners, you are moving with me. Good. Now, I've gotten 3 figures out of 1. I have this. It looks like a square, but when carrying out your calculations, trust me, it will be a rectangle. You'll find that one side is longer than the other. But look at it, it's just like a square. Try out with your calculations, one side will be longer than the other. We have this, one figure. We have this one here. Class, it is a triangle. And we have this one here, it is another triangle. So when we get the area of this rectangle, plus this one triangle, plus this other triangle, the total shall be the area of the whole figure, which is a trapezium. I know you must have enjoyed the lesson. Before I leave you, there is an activity for you. Here is an activity. Class, here is an activity for you. You are going to answer for me these 2 questions correctly, as you've been doing. Send the responses to our various platforms. Many of you have enjoyed using my WhatsApp, and I always mark you for the responses. Don't forget, stay home. Observe the social distances, and above all, please, watch all the guidelines given to us by the Ministry of Health, together with the presidential measures on healthy aspects. Love you. See you next time.